handout, but not in the PowerPoint. So, all of Chapter 1 is mostly about new vocabulary. You've used every single one of the words we're going to talk about today, but you haven't necessarily used them in the context of a statistics course. So the idea here is that you learn the new for this class definitions. You know, I always told students that algebra was a foreign language, statistics is a foreign language too. You have to learn the new words. So the first thing that we are going to talk about is data. Data is collections of observations such as measurements, genders, or survey responses. So basically it's information, and we're going to do some kind of work with that information. Okay? Statistics is the work we're going to do with that data. Statistics is the science of planning studies, experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. The goal of statistics is to answer a question. First, you have to find the question you're trying to answer. Then you have to figure out what information you need, what facts you need to collect, and how you need to collect those facts to be able to answer that question. Statistics is not about guessing. It's not about making some broad generalization that you don't have any basis in fact for. Statistics is not really a math course, although we use math in the course. It's not really a math course. It actually more properly is a science course. Usually the question that we want to talk about is a question about the population. Maybe the population we're interested in is all of the students that are enrolled this spring at Northeast State on all of its various campuses and all the online courses. It is the complete collection of all the individuals, and it may not be the people themselves. In fact, it probably isn't. It's the collection of all the information about all the individuals, and what you may be collecting is scores or grades or measurements of some kind, such as how tall they are, how much they weigh, what their ACT score is, what their GPA is, how many credit hours they're taking, how much they had to spend on books. So it's some kind of information that you collect from everybody, and that would be every student, for example, in the population of Northeast State students, spring 2018. That would be one population. There are lots and lots of populations. There's a population of all people in the United States. There is the population of all the M&Ms that have been produced in single-serving bags by M&M Mars Company since the beginning of when they started producing. That's a never-ending population. You'll never be able to collect information about that whole population. I could collect information about the population of the United States if I were the U.S. government, because I could take a census. I could collect information about the population of students at Northeast State dependent upon what kind of information it is I want. Because, for example, they have your ACT scores. If you took the ACT, they have all the students' ACT scores stored on the computer in a database. They have your current GPA. They have your current number of credit hours. They have the total amount of your financial aid award if you have financial aid. So I could collect that information because the school's already collected it. I could actually get information for the population. Just because I can doesn't mean that I want to get all the information, because the more information you have, the more pieces of data you have, the more work it is to actually enter all that data and do the calculations with that data. But the main thing to remember is the collection from the population is complete in the sense that it includes all of the individual's information that we're trying to study. Now, because that's not always easy, we can't always take a census, which is the collection of data from every member of the population, because we're not the U.S. government. Then we usually, when we do statistics, we work from a sample, which is a subset of the population. We have to be careful how we take that sample, and we're going to talk about that today in some detail. The subcollection of the members that you select from the population are the sample. For example, if I were talking about all of the probability and statistics students taking the course this spring at Northeast State, I might choose as my sample this class and my class that I meet at 3 o'clock this afternoon. And I might base my answer to some question I'm trying to find the answer to. I might base my answer on the information I collect from those two classes. Now, those two classes don't necessarily represent the whole population, because I've not included people from Elizabethton, I've not included people that are taking a course online, I've not included people that are in other instructors' classes, I've not included people that are taking the course at Kingsport Center for Higher Ed. So there's a lot of people that if I just choose to use my classes, that's not really a good representative sample, but it is a sample. Okay? It is a sample. Key concept is that the subject of statistics is largely about using that sample data to make what's called an inference about the entire population. We use a sample because, frankly, it's, number one, less information to have to deal with, but number two, if you choose your sample well, you can make good inferences about the population that sample came from. And largely, the whole first 3 chapters, we're going to be talking about how you collect data and how you calculate statistics. Then we're going to take a little break after the first test, and we're going to study a little bit about probability. Probability is only really necessary to the extent that you have some basic knowledge of it. So I'm not going to turn you into gamblers or teach you how to win the lottery. In fact, my best advice to you about lotteries, don't buy a lottery ticket because you're wasting your money. But we will talk about probability. And then after we've talked about probability, we'll put our statistical calculating ability together with our knowledge of probability, and we'll start moving into the area about making inferences. Inferences is when you make a decision based on the information you get from the data. A parameter is a numerical measurement, and it must be a numerical measurement of some kind that describes some characteristic of a population. Populations give us parameters. Those two words go together. They both start with P. A statistic is what we're going to use to estimate the value of the parameter that we're interested in. A statistic comes from a sample. It's the exact same calculations that you would do in most cases if you had the population data, but the difference is you don't have as many numbers or as many pieces of data to deal with. So it's quicker to do the calculations, and as I said before, if it's a well-chosen sample, that sample will represent the population. So you can use your sample statistic to estimate the value of a population parameter. So here's a question. Suppose a farmer wants to learn about the weight of his green bean crop. He's obviously interested in that because he's probably going to sell it. He's interested in the weight because they're going to buy it from him not based on how many green beans he produced, but how much the green beans weigh. So he randomly sampled 200 plants out of his whole entire farm. He randomly sampled 200 plants and he measured the weight of the green beans on the plant that he chose, or the 200 plants that he chose. What's the population he's interested in?
Is it all of his green beans?
Now, all of his green beans, his whole crop. What's the sample? What's he using to estimate that population parameter?
The 200 plants.
The 200 plants. So that's his sample, the 200 that he chose. And those are going to give him a statistic that will tell him about the population's parameter. So he can estimate the weight of the whole crop using the weight of those 200 plants. Okay? Let's try another one. Suppose a doctor wants to determine the average heights of his 3-year-old patients. He selects 52 of his patients and he records their heights. What's the population he's actually interested in? Yeah, all of his 3-year-old patients. That keyword there is all. He wants all of his 3-year-old patients. Now, it doesn't say how many 3-year-old patients he's got, but apparently he has quite a lot because his sample is 52 of those patients. So he's going to estimate the heights of all of his 3-year-old patients by taking the heights of the 52 that he chose as his sample. Here's one that's a little different. In a recent survey, 2,490 adults in the United States were asked if they checked their email account at least once a day, and 48% of those adults said yes. Who was the population? What was the target population?
Adults in the United States.
Right, all of the adults in the United States. Who's the sample?
The 2,490 adults.
The 2,490 adults that were actually selected and asked that question. So is 48% a parameter, or is it a statistic?
A statistic.
That's right, because it comes from a sample. Okay? Now, there's actually 2 types of data. The data that we've been talking about up to this point has been quantitative data. Something that's actually really a number. It has to be weighed or measured or counted. That's quantity. It is a numerical measurement. There's also qualitative data. Gender, eye color, the color of cars, the names of the courses you're taking, the majors of the students at Northeast State. Those are all categorical data. The responses to the questions that we would ask to gather that data would be words, not numbers. Now we have to be careful about distinguishing between those, because sometimes an answer can come to you and it appears to be a number, but it isn't quantitative data. For example, if I were to ask everybody in this room to write down the last 4 digits of their cell phone number. Everybody writes the numbers down, they hand them in to me, I have all these numbers. Is that data quantitative data? It's numbers, is it quantitative? No, why not?
Because it's not like a measurement.
That's right, it's not a measurement. It's not numbers that you count. You know, they don't count and give you the cell phone number. They don't measure your cell phone. They don't weigh it or try to find how long or wide it is to give you that number. It's basically like your name. It's just a label. It's a word. It's numbers used as a word. Okay? So just because you see numerals, which is the symbols for numbers, just because you see numerals as the responses or your data, don't assume that that means that you can start adding them up and dividing by how many you've got and all that kind of stuff. Because if I added everybody's cell phone number up and divided by the number of students in this room, I wouldn't have a number that means anything. It wouldn't tell me what the average cell phone number is. That's not what those numbers are for. So quantitative data is data that actually counts or measures something. You can have numbers used as categories. So quantitative data consists of the numbers or counts or measurements, for example, the weights of supermodels or the ages of respondents. Be careful to always include the units of measurement. Whether you're counting it or whether you're actually measuring it, you need to be able to include what you're actually counting or measuring. And if you can't, that might be a good indication that the data you've got is not really quantitative. So for example, the weights of the supermodels would have to be measured in pounds. That tells you how you would have collected it. The ages of the respondents tells you how many years or days or however they report their age, how long they've been on this planet. Categorical data consists of the names or labels that represent categories. For example, it could be the genders of athletes, it could be the shirt numbers on uniforms. There again, there's a number, but it's being used as a label. So I want you to decide, I'm going to give you a couple of minutes to do this, I want you to decide what these values are. Are they quantitative or are they categorical? Okay, let's see how you did. Gender is categorical. Temperature is quantitative. Eye color is categorical. Zip code is categorical. Average salary of a faculty member at Northeast State is quantitative. Number of days during the past week a college student has worked is quantitative. Social Security number is categorical. Heights of males is quantitative. The number of times a 2 is observed after rolling a die 15 times is quantitative. Yes, ma'am?
Could you explain why number 8 is a categorical?
Why number 8 is categorical?
Yeah.
How do you obtain the heights of males?
Oh, okay. You say it's because you find the numbers.
Right, you have to actually measure them, right?
Yeah.
One of the things we're going to do in this class, probably next time, is collect some data. And that data, one of the things we're going to collect is how tall are you? What's your height? And I have to bring in tape measures for you to be able to collect that data. Okay? Any other questions on this? That's a good question. If you don't understand, you should ask. Because you're not going to be the only one that has that question. There's going to be other people that have the same question. Any other questions on the answers about why it's one and not the other? Okay, we're going to see now how well you do understand. We're going to do a little group exercise. There's, at the bottom of the second page of your notes and the top of the third page, I think it is, there's some boxes. The first one says homes in a neighborhood, and it says categorical variables and quantitative variables. Then there's another one that says NBA players, with the same two categories under it. And then there's one that says cars on a lot in a dealership. Homes in a neighborhood is going to be all the people that I say are in group 1. NBA players is going to be the...
Oh, well, I like differently. See, I label this like quantitative and quantitative.
Kids live in the house?
Or
Okay,
lack thereof.
okay. Well, that would be 0 kids if they don't have any. more children living there. Before we can see the whole thing. Okay, take a look at the back again. You have a categorical that's not already been listed.
The colors of the mailbox.
Okay.
And then
Y'all did good. And quantitative?
how many homes are in the neighborhood.
How many homes total in the neighborhood? Okay.
Style of mailbox.
The style of the mailbox? And quantitative?
We said the number of people who live in the neighborhood altogether.
Okay, good job. One more round.
Zip code for categorical.
Okay, zip code, even though it's numbers, right? It's numerals, it's categorical because the zip code is assigned, but now, and this is not a criticism of your data because that's a good thing to have in. But would they all have the same zip code?
No.
If
Oh,
it's-
yeah.
Yeah, they would all have the same, but still, that's a good idea. Because zip code is something you can collect data about houses, about where they are.
Yeah, I'm pretty sure.
Okay, anything else on categorical for y'all?
Put the age of the home.
Age of the home, and that would be quantitative?
Yes, ma'am.
Okay. Okay. Table at the back, you want to add anything to either list?
Categorical, what the driveway is made of.
Okay. Okay. Anything else?
And then for quantitative, how long the driveways are on average.
Okay. So the length of the driveway. Anything else? Okay, back here.
We put address for categorical. Is that
Okay,
right?
address like in street numbers.
Yeah.
Okay. Anything else to add to quantitative?
Square feet of the house.
Okay, square feet. So those are all good answers. And you classified all of those correctly, so good job. Now we're going to talk about NBA players. For NBA players, give me one categorical and one quantitative variable.
For categorical, we put race or nationality.
Okay. Okay, what about quantitative?
Put player's height.
Okay. That's a good one. So let's see, this group up here.
We'll put the uniform number for categorical. And then their wingspan.
Waistband? Wingspan. Okay. Okay. See, back here.
We put eye color for categorical.
Okay. We are talking about people. What about quantitative?
Minutes played per game.
Good job. Get back over to this side of the room.
For categorical, we put what position they play on.
Okay. Position play. And quantitative.
Their shooting percentage.
Okay. Good job. What about y'all? You have anything to the list?
For categorical, we put endorsements.
Oh, yeah. Big deal for basketball players.
And then quantitative, we put salary.
Also a big deal if you play basketball, or for anybody else for that matter. Okay, back in the back.
We put where they're from.
Okay. So, let's see, hometown?
Yeah.
Okay. And
How many hours they practice each week.
okay. One more round you can add to the list. Anything that's not already on either list.
But whether they were starters, bench players.
Okay. And anything on the other one?
Shoe size.
Okay. Anything else? What about here? Have we exhausted your possibilities?
For categorical, we put last name on the jersey.
Okay.
And then quantitative, average points per game.
Okay. Anything else you want to add? Okay. What about back here?
We put for categorical, we put whether or not they have facial hair, married versus single, uniform color.
Anything else on quantitative?
Number of fouls per game.
Okay. Anything else you want to add? Okay, you've got questions.
Yeah, how is shoe size quantitative?
How is shoe size quantitative?
Yeah.
It actually is dependent upon how long the player's foot is. And that's something we are going to talk about in a little while, because while it's a quantitative variable, sometimes you have to think really hard about how you would measure that quantity. And I don't know if y'all realize this or not, but, and it's going to be a piece of data I'm going to collect about you, as a matter of fact. But American shoe sizes do not correspond to the rest of the world. If you look inside your shoe, regardless if it was made in this country or somewhere else, you're probably going to see two sizes. One of them is like 8, 8.5, 9, 9.5, 10, something like that. But the other one is going to be a number like 36, 37, 38, 39, and so forth. Those are actually the number of centimeters a person's foot is measured from the heel to the toe. And that's how they size shoes in other countries. So we're the oddballs. We assign shoe sizes based on a range of foot lengths, whereas in other countries, they actually measure feet and you buy whatever the length of your foot is. Okay? And it also brings up another question, which may or may not be what you were getting at. There's also a part of shoe sizes that if you included, you couldn't call it quantitative anymore. Because shoes come in narrow, regular, and wide. So there's a difference between a size 8 narrow and a size 8 wide. And once you start lumping it that way, then it's like, okay, how do you decide when it stops being narrow and starts being regular, and then where's the cutoff for wide? So you've started to assign letters as ways to quantify the shoe size, and there's not a way to quantify those letters. So you have to, sometimes you have to really think about things. Now, I promise I'm not going to ask you that kind of questions on a test. I'll ask you questions that, you're going to be able to pick out like this. But those are all things to think about, and y'all did a really good job. So, last group. Talking about cars on a lot at a dealership. Group 3 on the left.
Colors?
Okay, the colors of the cars. And quantitative?
Prices?
Okay, prices. Let's see. Second table. Oh, let's see.
Yeah.
Second table.
We did the make of the car, like whether it's a Honda or Toyota or whatever. And
Okay.
then for quantitative, we did like how many cars total on the lot.
Okay, good deal. And back in the corner. Ladies? Do you have a categorical and a quantitative?
I wrote, is make the same thing as brand?
Yeah.
Make is, but there is something else. I mean, there's a lot of different Chevrolets.
We put year for categorical and.
Okay, that's what we want to talk about. I'm going to kind of put it in the middle.
Then cost for quantity.
Cost of the car?
Yeah.
Okay.
Or asking price.
Okay.
Or the, I guess the price that was sold or the asking price, either or.
What about year? The year of the car. Is that categorical or is it somehow quantitative?
Could it be both though? Like depending on when it was released, could be categorical, and like how many years it's been like on the lot. Could it be quantitative?
Yeah, the number of years it was on the lot could be quantitative, so, or even like the length of time, not even necessarily years, because I don't think probably most car lots are going to want to keep that car sitting there for years, but the length of time, let's just put time on the lot. Now, year actually is the year that the car was released or the year that the car was made. Okay? A year is a measurement of time, but it's still an interesting question to consider, and that's why I asked us to talk about this, because some 19, let's say, for example, if we're talking about 1998 cars, some of them are actually produced in the first run, and they're actually produced in 1997 to be released in 1998. But then the ones that are selling well may be produced on up to, I think it's October of 1998. They're producing cars that are still released as 1998s. But somewhere around October, they start producing 1999 cars. So in that sense, then, the year of the car, that's actually the model year. And it's not really a measurement of time. It's a label that's attached to the car indicating approximately what year it was made. It's more of a label, so yes. Okay, let's come back around to this side. What do you have to add to categorical and quantitative?
The radio.
Whether or not it has a radio?
Accessories.
Accessories, okay. Like air conditioning, hopefully. Okay, what about quantitative?
Gas per gallon.
Okay, mileage, gas mileage. Okay, this side of the room.
You said the model of the
Okay,
car.
the model, which is not the same as the make. The make is like Chevrolet. The model might be Malibu.
Right.
Okay, what about quantitative?
The down payment.
Okay, the amount of a down payment. What about in the back? Do y'all have anything to add to the list? This one's a little bit more challenging sometimes.
Speed,
Excuse me?
speed for quantitative?
Okay. The speed that it'll go to, it's top speed. That might be important if you're looking for a sports car. Anything else on categorical?
I have all those up there.
Okay. Any of the other groups, do you want to add anything to either list?
No, I think we said everything.
Yeah, this one actually, it's kind of hard to come up with a whole lot of them. And these actually kind of cover, I mean, when you talk about accessories with a radio, without, with air conditioning, without, things like that. So accessories covers a lot. Y'all did a good job, and you obviously understand how to classify your data pretty well. So let's go back to the PowerPoint. And talk about working with quantitative data. Quantitative data can further be described by distinguishing between discrete and continuous data types. So now remember, we're talking about actual numbers and measurements, okay? Discrete data is the result when the number of possible values is either a finite number or a countable number, and the key word here is countable. If it's discrete data, the way that you quantify that data is you count it. You pick it up and put it down, or you do like I do when I went around the room and named the groups. You're actually counting the data, okay? Like, for example, the number of eggs that a hen lays. But the number of values here, in this case, would be no eggs, 1, 2, 3, 4, 5. You also count money. I don't want you to get the idea that there can't be decimals in discrete data, because there can't. Money is measured to the nearest cent. So you have $1, $1 and $1.01, $1.02, $1.03. You're still counting that money. Okay? So any monetary variables that you have, that is discrete data. Okay? It is discrete. Continuous data, on the other hand, and this is the definition the book gives you, but I like my definition better. If you quantify the data by measuring it with a yardstick, with a measuring cup, with a thermometer, with a tape measure, with the odometer on your car, if you measure it with a measuring device, that makes it continuous. okay? Now, you may not report the entire continuous variable. For example, if I were measuring the weights of bags of candy, I might report those weights to the nearest gram. And I would have candy that was 458 grams or 459 grams. But that doesn't mean that that weighed exactly 458 grams. It might have weighed just a little teeny bit more, and it just depends on what measuring scale that I used as to how sensitive it is to tell me if it was 468.32979 grams or how the device rounds. But that's still continuous data. It has to be measured. You can't count it, quantify it. And the example given here is the amount of milk that a cow produces is 2.343115 gallons a day. So decide whether these data are discrete or continuous. How do you measure them? How do you quantify these? If you count it, it's discrete. If you have to have a measuring device, something besides just your two hands and your brain, it is continuous. Got 4 questions. Okay, why is the amount of water in a cup continuous and not discrete?
You have to measure.
You have to measure it. You have to either get a measuring cup or, if you're going to measure it in ounces, maybe you can even use, in chemistry they use beakers and flasks, so you can measure that way. The number of desks in a middle school classroom is discrete because
You can count it.
you counted them. You didn't have to pick them up. You didn't have to set them on a scale. You didn't have to take a ruler and determine, okay, this is one whole desk. You just counted them. Same thing with the number of cars in a grocery store parking lot. You sure don't want to pick those up. And people might probably call the police and wonder what you're doing if you start trying to measure the length of their car or something like that. But if you're just trying to quantify the number of cars, you're just going to stand, there are 1, 2, 3, 4, 5, 6, 7, 8, and count them. The weight of an elephant in pounds. If you've got a big enough scale, you can put him on the scale, and depending on the size of the scale and how it actually spits out the weight, this one says in pounds, then that is a continuous measurement because you had to have the scale. Okay, in front of you, you have a list of data, and I want you to tell me if it's discrete or is it continuous. This is back on the page before we did the group exercise. These data. So only for the ones that are marked Q, classify them as discrete or continuous. Temperature, salary, number 5, number of days, number 6, number 8, heights, and number 9. All the ones that are quantitative data tell me, are they discrete or are they continuous? Okay, does anybody need a little bit more time? Okay. Okay, how do we quantify temperature?
On a scale, like Fahrenheit or Celsius.
Okay, on a scale, using a thermometer. Okay, and scale could be Celsius, Fahrenheit, or Kelvin. Three different scales, but for every one of those scales you still gotta have a thermometer. So that means it is continuous. Okay? How do we quantify the average salary of a faculty member at Northeast State?
Discrete.
That would be money, so it is discrete. That's right. The number of days during the past week that a college student has worked is quantitative. How do we quantify that? It's discrete because we count the number of days. How do you quantify the heights of males or females or anything else?
Measure with a ruler.
You know, you have to measure it using something, a meter stick, a yardstick, a tape measure, but you got to have something. You can't just kind of look at them and say, okay, you're 72 inch. Now, most of us are not quite that good. What about the number of times you see a 2 when you roll a die 15 times? That's discrete because you counted how many times it landed with a 2 on top. So good job. Now there is one more way to classify data, and that's called levels of measurement. The first for declassifying your quantitative data was the decounter you measure it. But there's also a way to actually decide what level of measurement it is. First thing that we have is something called nominal level data. Nominal, for probably nobody takes Latin anymore. I went to high school at a time that everybody that was going to college, for whatever reason, had to take Latin. I've never really regretted it, even though I really didn't care for it too much at the time. But I've never regretted it because learning Latin has made it easy for me to learn to speak other languages. Because Latin actually gives us the root words of our own English words that we use, and it's very similar to some of the foreign, or I don't want to say foreign, but other languages have a similar word for the same concept. So nominal comes from the Latin word nomen, and nominal means name because the word nomen in Latin was a person's name. That's an easy way to remember. Nominal level data is the names of the category, and it's just a name. You can't put those names in any kind of an ordering scheme where it's a value-based ordering scheme, where one of them is better than another one, or lower or higher than another one. Alphabetical, by the way, is not an ordering scheme. Just because your name starts with an A doesn't mean you're better than someone whose name starts with a Z. That's just a way to put things in a certain order because that's just the way our brains want to classify stuff. But survey responses such as yes, no, and undecided. Well, depending on what the question is, yes is probably no better than a no, and undecided isn't any better than either one. So those are just categories, and you count how many people fit in each category. Ordinal level data, on the other hand, is data that can be arranged in some value-based order, where one is more valuable or better than another one. Differences between the data values can't be determined because we're still talking about words. For example, course grades A, B, C, D, F. Is one of those more valuable than another one? What's the most valuable grade to you? You want an A, right? You might take a B. At the end of the semester, you may be to the point like, oh, God, just let me get a C. You know, I'm that way in the history class, so I got you. I understand. Nobody wants that one. That's the lowest one. That's the least pick. Nobody wants the F. You'd rather have a D than an F. Okay, so there's an ordering scheme there. It's still just labels, but there's an ordering scheme. When you rate service in a restaurant, excellent, good, fair, poor. If you're the person waiting on that table, you want your ratings to be excellent and good. You don't want those other two. So that makes some of those words better than others. Okay? Interval level data is, actually, I can give you quite a few examples, but it's hard to think of very many examples, more than about maybe 5. Interval level data is when you actually do have numbers. It is numerical. The years. 1000, 2000, 1776, 1492. Those are years. Those measurements are measuring something from what's called the beginning of time, or there was a year 0. We have AD and BC. BC scientifically is referred to as before the Common Era, and AD is after that. So instead of expressing those years with negative numbers, which we normally would, then the BC years are referred to as BC, or before the Common Era, which means they occurred before that dividing year. There's no natural 0. Year 0 did not mean there was no year that year. There was a year. It was just the first year that they counted from. So you can find the difference between years, but you can't decide that one year is twice as good or twice as much as another. So for example, 2000 isn't twice as good as the year 1000. 1,000 years have passed, you can find the difference, but you can't say one is twice as much as the other. You can only subtract and find how many years has passed from one to another. Okay? Temperature is another one that is actually interval level data. When I got up this morning outside, it was 33 degrees. When I got up about a week ago, it was 66 degrees. Okay, that's a 33 degree difference. Is it twice as warm when it's 66 degrees? Is it half as warm when it's 33 degrees? 66 degrees is just nice outside. 33 degrees, it's cold. You know, there is no comparison of twice as warm or half as warm. So temperature is another one that's interval level data. Those are the best 2 examples I can give you. Yes?
Okay, so it's numerical, but one number can't be better than another number, right?
Well, yeah, one can be more than another or less than another, but not better in the sense. And not only can it not be better, but there isn't a ratio type of relationship. You can't say that 2000 was twice as far away as 1000. It doesn't have that kind of relationship. Okay? Now, the level of data that most data we're going to find a really good use for is called ratio level data. And the easiest way to tell the difference between interval level data, you might want to write this down, the easiest way to tell the difference between interval level data and ratio level data is to ask yourself, what does 0 mean? When the temperature outside is 0, did that mean there was no temperature that day? No, it just meant it was cold. Okay? If you go over to the bookstore and you don't buy any books because you already have all your books, you spent $0 in the bookstore today. What does 0 mean? It means you didn't spend any money in the bookstore today. You didn't have to. So it was none. That's called an inherent 0. An inherent 0 means there's none of whatever it is that you're quantifying present. How many children do you have? What does 0 mean? You don't have any children. None. How much money do you have in your pocket right now? If you don't have any money in your pocket, 0. Okay? So if 0 means none, then it's ratio level data. If 0 just means it's another quantity, then 0 doesn't mean none, it's just another number, like in temperature or year 0. Now, if we're talking about credit card balances, and here again, we're talking about money. Money is always a good piece of data we're always interested in. What does 0 mean in terms of your credit card balance?
There's no money left.
Yeah, well, but you don't have to make any payments either. So your credit card balance is 0, means you don't have to make a payment that month. You have no money that you owe. What if your bank account balance is 0?
You don't have any money in that account.
You don't have any money in that account. So are you going to write a check?
Yeah.
Only if you're willing to pay the $30 service fee. Okay? Can your bank account be negative?
Yeah.
Yes. So does that change the fact that 0 means you didn't have any money? No. So when you're talking about money, money is ratio level data, even if it's money as applied to bank account balances or whatever other kind of balances that you might be looking at. The other measurement, or the other thing that's inherent in ratio level is 0 represents no cost for a book, but a $100 book costs twice as much as a $50 book. A $10 book costs half as much as a $20 book. Good luck finding a $10 book. So, for this list of data, classify the level of measurement. I'm going to give you a hint first. First, go down that list and classify all of those as either categorical or quantitative. Because the categorical ones are either nominal or ordinal. Only when you have quantitative data is it interval or ratio. So classify it both ways. Does anybody need a little more time? Okay, let's discuss, because this isn't a contest, it's to learn. Height is a quantitative variable. What does zero height mean?
You're not alive.
Yeah, there's no NBA player there. There's no basketball player there to measure a height. So there's no height. Okay? Zero means none. But even though that might not make as much sense to you, can you quantify it by talking about one person is twice as tall as another? Or 60% as tall as another person? Or 90% as tall as another person? Or maybe even this person, this really tall person, is 120% of the height of this other person that's short. So yeah, that kind of makes sense. So the ratio makes sense. Morning temperatures at the Tri-Cities Airport last week. Now, if you got that one wrong, you know, I told you that was there's only two that I can really give you examples for interval, and that's temperature and years. That's it. There may be others, but I've never come up with anything we commonly collect that actually fits in interval level ratio level data. Zip codes. It's a number, right? Is it quantitative? No. Therefore, it cannot be ratio or interval. It has to be nominal or ordinal. So that the idea between those is, okay, can you put zip codes in a meaningful order? What does a zip code tell you about a place? Where it is. Okay, so Jonesboro has a zip code 37659. My zip code, a little further down the highway, is 37690. Does that mean my place is better than Jonesboro? No. It just means it's a different location. Okay? Distances traveled by students over the Labor Day weekend. How do you quantify the person that didn't go anywhere? Zero means they didn't travel. They didn't travel any miles. Okay? So therefore it is ratio. Somebody that went 50 miles went half as far as somebody that went 100 miles. The actual contents in ounces of chips in a bag of baked lays that are labeled 10 ounces. Okay, it is quantitative. It's continuous because they use a measuring scale to measure it. It is ratio because the empty bag has no chips in it, it has no weight. Well, actually the bag has weight in it, but not the actual contents. If there's no contents, then there's no weight. Okay, so that's zero. Ratings of above average, average, or below average for new movies. It's not quantitative. Therefore, it has to be nominal or ordinal. It's ordinal because,
Like best or worst.
yeah, you're ranking it from best to worst. Okay? Whoops. And the years in which statistics students in Math 1530 were born. Notice I didn't say their age, I said the year they were born.
Is that ordinal?
That's actually interval because the year you were born is a quantity. Okay? But it's interval because if you were born in 1999 and somebody else was born in 2009, all you could say is, well, then that student is 10 years younger than me. Okay?
How is it not categorical?
It's not categorical because a year has to be quantified. The year you were born is the year that you were born in, and that year is the number of years that have passed since year 0. Okay? That's how we're quantifying it.
And I had one more question. Why are zip codes ordinal? Because you can put the numbers in order. It just doesn't.
But is one better than another?
No, but you can still put them in an order.
Okay, but I can put the first names of everybody in this room in alphabetical order. Does that make one name better than the other?
No.
Okay, it's a matter of, is it a value-based order? Okay? You know, is one more valuable than the other? Okay? That's a good question, though, and thank you for asking that, because that one's hard to clarify for a lot of people, because instantly we think about putting things in a certain order without considering whether that means that the one at the end of the list is better or worse than the one at the beginning. So you have to think about it being a value-based order. Okay, the last thing we're going to talk about is the basics of data collection. And one of the things that we're going to talk about is that we have to be careful of small samples. You shouldn't make conclusions based on samples that are too small. For example, you don't want to base a school suspension rate on a sample of 3 students. You might even get the best 3 students in the school or the worst 3. And that wouldn't be representative of the whole school. And all of this is not in your notes, so that's okay. Don't worry about it, because we're not going to spend much time on this. I will caution you that when you're collecting data, a voluntary response survey is one where the participants decide for themselves whether or not they want to answer. We get surveys in the mail, you get a phone call that says, hey, I'm conducting a poll. You choose whether or not to answer those questions. If the survey or the phone call with the poll is about something you are passionate about, if it's a political poll and you are heavily leaning one way or the other, you're going to answer that poll. You're going to answer that survey. But if it's something you really could care less about, then chances are you're going to say, I'm sorry, I don't do this, and hang up or throw the survey in the trash. So typically, the only way that you get a voluntary response survey is that you get biased data. Data that only comes from people that have strong feelings. That is not a good sample. So now we want to talk about the basics of how do you collect data. And those are the 2 cautions about what you don't want to do. Statistical methods are driven by the data you collect, but you typically want to obtain data from 2 sources. Either an observational study, which is where you just watch and count and collect, but you don't do anything to make people act a certain way. Or an experiment where you actually do something to the people or the objects of your interest. For example, if I gave you a test, if I gave you the final exam, the first day of class, and then I'll wait till the end of the term and I give you the final exam again, what do I hope happens between that first final exam and that last one? Improvements, okay? What did I do between the first time I gave you that test and giving it to you at the end of the term?
You taught us that.
Yeah, I taught you, or I tried to teach you, but I did something, okay? I tried to influence the results of the second test. That's an experiment. I'm trying to determine if my teaching improved your score. So an observational study is when you observe and measure specific characteristics, but you make no attempt to modify the subjects that you're studying. Just collect information from them. Observing doesn't mean that I can always figure out what I want to know just by looking at you. It means that I may have to ask you questions and observe your answers. Okay? An experiment is when you apply some treatment and then observe the effects on the subjects after you've treated them. So, number one, in order to determine whether taking aspirin prevents heart attacks, 300 people were involved in a study. 125 people were given an aspirin and 175 were given a placebo, which is just a little white pill that looks like an aspirin but doesn't have any aspirin in it. Is that an observation or is it an experiment?
An experiment.
It's an experiment because you actually did something to both groups of people. You did something differently from one to the other, but you did something, so that's an experiment. A study of how elementary students color in their coloring books. How would you collect the data?
Observational.
Yeah, you just watch them. Just watch them to see how they do it. Now, we also have types of samples. We have 5 minutes left, so I'm not going to actually do this part, and I didn't plan on doing this part today. We're going to do something in class next time because these samples are not nearly as easy to understand if I just give you definitions as if I actually work with you. So I'm not going to finish that PowerPoint right now. We're going to take this up next time. I usually give you a break, but I did not give you one today because we had to get through so much vocabulary. So I'm instead going to let y'all go at this point. Do be sure and look at the homework for Chapter 1. You don't necessarily have to finish it, but you do need to at least start on it. And as you work on it, go ahead and submit what you have as far as you've got. Because I will be looking at it, and you'll have a chance to modify it if I tell you that you're not answering correctly.
In Pearson or
In showing, your Pearson homework is always there, and it's ready for you when you're ready to work on it.
And there's like a few ones having to make a percentage estimate. Yeah.